One of the best investments you can make in your home is to add square footage. The basement's one of the easiest places to do that, but when you add habitable space anywhere in your home, you need an egress, an exit to the outside. Egress windows are a great way to do that, and that's what we did here. It's a big project, but let me show you how we did it. So we're about to start digging our really big hole here, but before we do that, we made sure to call to have the underground utilities located. It's free to do, and it's absolutely important when you're digging a big hole like this. At the beginning of a project, you don't want to hit any power, gas, or water lines. It'll be a huge expense, not to mention very dangerous. It's free to call, so call before you dig. I rented a mini excavator to make the digging much easier, and it was well worth the money we spent just to avoid hand digging. Be sure to have a plan for the dirt that's going to be removed. It will be way more than you anticipate. We ended up taking the nearly 10 yards of dirt to a nearby compost site. Once the hole was dug and free of loose dirt, I dug a trench underneath the house and fed a drain pipe to meet the drain tile system. This is a process required by the city to prevent water from pooling and then freezing against the house, which could cause damage to the foundation. Once the drain pipe is in place, fill the hole with clear rock. Then I tamped the loose dirt to create a slope towards the drain, and then covered the bottom with geotextile fabric, followed by another layer of rock that I leveled and tamped. We've leveled out the bottom of our well, and because the well is so deep to fit our window, we've exposed the footing, which means we need to protect the footing from frost. We're going to be adding 4 inches of rigid foam to the bottom of the well. Then we'll put a layer of fabric over that and then add some more rock for the base for our timber well. I use a 25 psi rated rigid foam. This is important because we don't want the rock to crush the insulation when we add a bunch of it later on. And this is going to be the base for our timbers. I leveled and tamped it, and then I was ready to start building the timber wall. It is critical that the first course of timbers is level along the length and the width of the wall. To do this, you might have to tamp and move rocks to position the first course. The next layers go a lot easier. I make sure I alternate the overlaps at the corners and fasten them to the previous course every 12 inches with 8-inch timber screws. After a few courses of the timbers are up, I unrolled geotextile fabric along the dirt walls of the well, folded over the edge of the hole. The fabric keeps the dirt from entering and clogging up the drainage space that will be behind the timbers. I built up several more courses of timbers and then filled the bottom with more clear rock. So before we put the last course of timbers to complete our wall, I want to fasten this angle here. It's made of steel, coated with zinc, so it's going to be very corrosive resistant. But what that'll do is it'll keep the wall in place as we start to backfill with the rock back here. When we backfill the rock, all that pressure will push against the wall. The steel will keep it in place. I drilled pilot holes with a hammer drill and fastened it to the block with construction adhesive and concrete screws. The retaining wall needs to be allowed to shift slightly, so we are not fastening the timber wall to the angle at all. I attached the last course of timbers and then filled the space outside the well with clear rock. The rock allows water to drain away from the wall and give it space to dry, adding longevity to the treated lumber. Fold the rest of the fabric over the rock and then cover the fabric with topsoil, maintaining a slight slope away from the well. As it always happens in remodeling, I ran into a challenge where our new well meets the stucco siding. My solution was to add a drip ledge above the well to create a smooth transition from the existing stucco to the thicker insulation and cladding I'll be adding in the following steps. I made a cut across the well a few inches above the timber wall to remove the stucco. Then I lightly pried the layers from the house and cut any nails that were in the way with an oscillating multi-tool. Then I slid a piece of flashing behind the stucco and the water-resistant barrier. Finally, I ripped a piece of 2x6 cedar to about 4 inches, giving it an 8-degree bevel, then attached it to the wall with a few lag screws. Next, we're going to be working on laying out the window. Now our window opens this way, so we're going to scooch the opening over a little bit, and we have to make room for a wood buck on either side of the window, plus some space to add shims and to insulate the window. So we're going to take the width of the window and add about 4 1/4 inches to it. We're going to do that for the width and do the same thing for the height of the window too. Add that 4 1/4 inches for those same reasons. Once we have it laid out, we're going to cut right through the block. So when I'm drawing a layout like this, I like to mark out each part. So I'm marking where the buck is, the space between the buck and the window, and the window. This way I can make sure my measurements are nice and precise. Now before we put a big hole in this wall, we need to make sure that the house is properly supported once the wall is removed. To do that, we need to add a header above the opening. Now I referenced the residential code book span charts to figure out the size of the header we need, and it ends up we need 3 ply 2x10s. Now we already have 1 ply as the rim joist, so I'm going to be adding 2 more plies to that rim joist using glue and screws. Now there's a few things I have to remove to make room for that, but we're going to get started. So I started by removing this block that was in the way, and then I had to cut a few nails that were in the way of me putting the header in. So I glued the headers in place and then fastened them with lag screws. So what most people use when they're cutting out block like this is a 14 or 16 inch concrete saw. You basically have to cut from the outside and then go inside to finish the cut, meaning you've got water inside and gas fumes inside. What we're trying out this time is a chainsaw version of that, outfitted with a diamond blade chain. Now with this we can make 1 cut from the outside going all the way through the block, keeping the water and the gas fumes outside the house. Let's try it out. Then the fun part, knocking the big blocks out of the opening. Once everything was removed, I filled the bottom cores of the block with concrete. I cut 2x12 pressure-treated wood bucks to fit the width of the opening and fastened the top buck to the bottom of the sill plate. Then using shims, I leveled the bottom buck and gave it a slight pitch outside. Then fastened it to the core fill blocks with concrete nails. I sealed the bucks to the block wall with a bead of caulk and then began flashing the opening. I used 6-inch wide flexible flashing tape to create a window pan. I started by covering the front of the sill, wrapping the tape up the sides about 6 inches. Then I carefully stretched the tape around the corners and the front of the bucks. Then I applied the tape to each side, overlapping the tape on the sill. Finally, I covered the top of the bucks, making sure to adhere the tape up the block wall, sealing any entry points where water could get inside the framing. I applied a continuous bead of silicone along the sides and top of the window bucks. Then with a helper, set the bottom of the window in the opening and carefully tip the window up until the nailing flange meets the window bucks. With your helper outside holding the window, head inside to position it. Raise the window off the sill and level it using a few shims. Then center the window in the opening and check the sides for plumb. Use shims to hold the sides plumb and have your helper nail the top and sides of the window's nailing flange. The dirt we removed from against the house was actually insulating the basement, and we needed to replace it with a 2-inch layer of rigid insulation. This is the reason we positioned the window bucks proud of the block wall. I pressure fit the insulation between the wood bucks and a few 2-inch pressure treated wood cleats that I fastened to the wall. After fitting the insulation around the window, I sealed all the seams with sheathing tape and nailed on a piece of drip cap over the window. So the window is pretty much wrapped up. The only thing left to do is to trim it out. But before we do that, I'm gonna move on to cladding the inside of the well. It will get wet down here, so before I just go ahead and slap the cedar on, I'm gonna add some fir strips every 2 feet or so. It'll keep the cedar away from the wall, allowing air to get behind it and allowing it to dry. To prevent the pests from finding a home behind the cedar cladding, I lined the inside of the well with a roll of fiberglass screen mesh. Then I used cedar deck boards to clad the inside of the well. I built in a few steps using 2x4s, cut to length with 30 and 60 degree angles to fit inside the corner, then fastened them with leftover timber screws. Then I fastened the cedar decking around them to match the inside of the well. I ripped a few pieces of exterior trim to 1¼ inches wide and fastened them on edge around the window with composite decking screws. After fitting in the final wall of cedar cladding, I sealed the window to the trim, capped the top of the retaining wall off, and gave the well a few coats of tung oil to finish it off. So the window's complete, bringing this space up to code and providing us an escape route in case of an emergency. It also brings in tons of natural light in an otherwise dark basement. For more projects like this, head to familyhandyman.com.